Force System Resultants. Good day, everyone. In this lecture, we will discuss force system resultants in statics. We will learn how forces create moments, how to calculate moments in both two-dimensional and three-dimensional systems, and how to simplify complex force systems into equivalent resultants. These concepts are fundamental for analyzing structures and mechanical systems. Objectives. At the end of this lecture, you should be able to calculate moments in 2D and 3D, determine moments about a specified axis, understand couple moments, find resultants of non-concurrent force systems, and replace distributed loads with equivalent point loads. These skills form the basis of rigid body analysis. Moment of a force. Scalar formulation. A moment describes the tendency of a force to rotate an object about a point. The scalar equation is moment equals force multiplied by the perpendicular distance. In 2D problems, counterclockwise moments are usually taken as positive, while clockwise moments are negative. The right-hand rule helps define the moment direction. Cross product. In three-dimensional analysis, moments are represented as vectors using the cross product. The equation is m equals r cross f, where r is the position vector and f is the force vector. The cross product is not commutative, meaning reversing the order changes the sign. This method allows us to determine both magnitude and direction of the moment. Moment of a force. Vector formulation. The vector formulation uses the relationship m equals r cross f. The position vector starts from the reference point and ends on the force's line of action. According to the principle of transmissibility, moving a force along its line of action does not change its external effect or moment. For multiple forces, the resultant moment is the sum of all individual moments. Principle of moments. Varignon's theorem. Varignon's theorem states that the moment of a force is equal to the sum of the moments of its components. Instead of working with the original force, we can resolve it into horizontal and vertical components and calculate their moments separately. This often simplifies calculations significantly. Moment of a force about a specified axis. Sometimes we are interested in the moment about a specific axis rather than a point. This can be calculated using either a scalar approach based on perpendicular distance or a vector approach using the scalar triple product. The vector method projects the moment onto the desired axis. Moment of a couple. A couple consists of two equal and opposite forces separated by a distance. Because the net force is zero, a couple produces rotation without translation. The moment of a couple depends only on the force magnitude and the separation distance. It is considered a free vector because it can be applied anywhere on the body. Simplification of force and couple system. A complex force and moment system can be simplified into an equivalent resultant force and a resultant couple moment. The resultant force is obtained by summing all forces, while the resultant moment is obtained by summing all moments. This simplification makes engineering analysis more manageable. Different force systems can be simplified in different ways. Concurrent systems may reduce to a single force, while parallel systems can be represented by a single force acting at a specific location. In three-dimensional systems, the final result may be a wrench, which consists of a force and a collinear moment. Reduction of a simple distributed loading. Distributed loads can be replaced by an equivalent point force. The magnitude of the equivalent force is equal to the area under the load distribution curve. The location of the force is at the centroid of that area. This approach simplifies the analysis of beams and structural members. Key formulas recap. This slide summarizes the key formulas covered in this lecture. Review these equations carefully because they are frequently used in statics problems. Understanding when and how to apply each formula is more important than simply memorizing them.